that basic things of SI unit is that length, mass, and time are the basic fundamental quantities. So that quantities that can be measured and in terms of its laws of physics are described are called physical quantities. So example for that length, mass, time, force, energy, etc. So these three things are very important. That length that we are going to use, how we are going to measure the length, mass, and other things. These are all the physical quantities: speed, acceleration, volume, velocity, weight, stress. These are all the different physical quantities we are measuring in a different units. So physical quantities can be classified into two types. One is the base quantities are called fundamental quantities. Another one quantity is called derived quantities. So base quantities or fundamental quantities are one branch of physical quantity. That the example for the base quantity is distance. Can take that as example for distance. Let's one example. So distance, length, mass, time, electric current, temperature, luminous intensity, time. These are all the example for the base quantities. And another quantity is derived quantity. That quantities that can be expressed in terms of fundamental quantities are called derived quantities. Example for that, say area, volume, velocity, acceleration. These are all the examples for the derived quantities. So these are all the examples for the derived quantities. So the derived quantities, the fundamental quantities are very important. So now we are going to see the definition of the unit and its types. So base quantities has the unit that units are called base units or fundamental units. The arbitrary inclusion standard of measurement of quality, which is accepted internationally, is called unit of the quantity. That quantity is used to measure the base quantity is called base unit or fundamental units. And system of units and another one thing is derived units. Derived units is the unit which cannot be derived in any other fundamental quantity is called a derived unit. So different types of measurement systems are there, that is CGS system, FPS system, and MKS system. So these are the three types of system. In that three types of system, we are measuring that length, mass, and time. So first thing is CGS system. So CGS system is the Gaussian system. It's already called as Gaussian system. That is fundamental units of centimeter, gram, second. And FPS system is foot, pound, and second. Then another system, metric system, or it's called MKS system. That system has the meter, kilogram, and second. For the MKS system, that FPS system or that is called a British system. The last one is MKS system. That's based on that meter, kilogram, and second. The three basic units of measuring length, mass, and time respectively. So these are the three types of measurement system. Then SI systems. That SI system initially that metric system since 1960 we are measuring that. That universally it is accepted that system is in 1971. Afterwards we are using that system international. That is called SI system. So system international, the units, the system international of units. That's called SI units. Okay, it's called SI units. So in 1971, international usage of scientific, technical industries and commercial work established that the SI unit. It is used to measure the scientific, academic, industrial, and that other purposes. So basically, SI system has the 7 base quantities, are the fundamental quantities. The 7 fundamental quantities. Fundamental unit quantities for SI system is 7 things that are length, that is letter small m. It is unit is meter, and second one is that meter is defined as the meter is the length of the path traveled by a light in vacuum during an interval of 1 by 299, 799, 4580 period of part of the second. So 1 second is divided into that much of period, that is equal to 1 meter. Next thing is mass, unit is kilogram, symbol kg. The kilogram is equal to the mass of the international prototype of kilogram at PIBM. So PIBM is the place of Bureau of Weight and Measurement source near Paris in France. So we kept that 1 kilogram stone, that is the 1 year, that is equal to 1 kilogram. Then third one is time. The unit of time is seconds. That denote the letter S. Then 1 second is defined as the. So how to define that 1 second means? So it has a, you are using the atomic clock cesium-133 atom. So that atom has the transition period. That is jump from the one orbital to the another orbital. That is the transition time. So using that we are calculating the time period. Next one is the electric current. The unit of electric current is ampere. It's not the letter A. So 1 ampere is defined as the constant current which it maintain a two parallel conductor of infinite length. The two conductors as the cross section is negligible. That separate the distance of 1 meter apart in vacuum. So produce the conductance of force equal to 2 into 10 to the power of minus 7 Newton meter inverse. So the two conductors experiences this much of force that is equal to 1 ampere. So infinitely long two conductor that is attracted that much of force. Then thermodynamic temperature that denote the letter Kelvin, unit is Kelvin, then denote the letter K. That value is equal to 1 by 273.16 of the thermodynamic temperature of triple point of water. Triple point of water is the temperature at which saturated vapor, pure and melting ice are in equilibrium. Then next one is the luminous intensity. That unit is candela. It's denoted the letter CD. It's candela. So candela is the depend on the luminous intensity in a given direction. A source that emits the monochromatic radiation of frequency 540 into 10 to the power of 12 Hz and that has a radiant intensity in that direction of 163 watt per steradian. So light is divided like this. So it's a one light, that light has the frequency and this much of angle. That the particular angle is equal to called 1 candela. Last one is amount of substance. Unit is mole. It denotes the letter MOL. So the mole is amount of substance of the system which contains many elementary entities, atoms of 0.012 kilogram of carbon 12 atom. So in carbon 12 atom, we are going to take 1 by 12th of the carbon atom. That is equal to 1 mole. And other two supplementary quantities are there. What is the plane angle? Another one is the solid angle. The plane angle, that unit is radian. That symbol is RAD. Then solid angle, that is radian and RSR. So this first one is called radian. That's the theta, d theta. And that surface, that length is called ds. That radius is called r. So that is measured in that radian. So this is a two-dimensional picture. See that this is a two-dimensional picture. So two-dimensional picture, we are using the plane angle and unit is radian. So the ds is increases. So it is a two-dimensional picture. So ds equal to r. That is equal to 1 radian. It is side angle. It is a three-dimensional picture. So it is steradian. Unit is steradian, SR. So you can take that small area dA. That small angle is d omega. Then radius r. So that is d omega equal to dA by r square. That is equal to 1 steradian. These are the important quantities for that angle. So that is 2-dimensional and this one is 3-dimensional. Okay, so that 3-dimensional. These two things are used to measure the angle. But other things are that other units, that is symbol and that SI units and values. So minute, that is 60 seconds, hour equal to 360 seconds, 40, year, and then next degree, 1 degree, then 1 liter, 1 ton equal to 1000 kilogram, then carat 200 milligram, bar, curie, Wangen, and quintal. Quintal means that is 100 kilogram. 1 pound, 1 air, 1 hectare, and standard atmosphere. These are all the constant values. We are using that symbol that is equal to for the constant values. These are the derived quantities. Using the fundamental quantities, we are deriving these quantities. So these are all some example for the derived quantities. So unit conversion from one unit to one system to another system. So that is the unit conversion. Then the Taylor tape, land tape, and survey chain. These are the example for that measuring instruments. So this is the land tape. This was all the things are used to measure the distance. Survey chain. So all the instruments are using the measure the distance.